Learning objective F, we're going to fully factor by finding all the zeros with complex zeros using long division. So let's go back to the problem we ended in learning objectives D and E and finish off part B. So here's where we left off on learning objective D and E. Part B wants us to find the remaining zeros and their multiplicity. So again, this was a third degree polynomial. They told us 2i was a solution, so negative 2i was a solution. Now, when we looked at the graph, it was not an obvious zero, so I couldn't get it from there. So now we have to figure out how to get that third answer. What we want to do is we know two of the zeros. So we can take the two zeros, write them as factors. If we take the factors and multiply them together, we can then long divide it out of here, and we'll be left with one additional factor, which will let us to find this zero. Let me show you what I mean. So this right here was a third degree polynomial. Now we know that 2i and negative 2i are the zeros. So let's go ahead and write those as factors. That'd be x plus 2i, and it'd be x minus 2i. Now what I want to do is to multiply these together. And then after I multiply it together, I'm going to go over here and make it my divisor and put it here. So let's get started. X times x is x squared. X times negative 2i is negative 2ix. 2i times x is plus 2ix. And positive 2i times negative 2i is negative 4i squared. Now these two cancel out, so I'm left with x squared minus 4. The I squared is negative 1. So what this becomes is x squared plus 4. This is now my divisor. So I'm going to take this and put it over here. X squared plus 4. Now what I can do is long divide this divisor out of here. The quotient I'm left with will be the third factor I need. Let's walk through it. To make an x squared a 3x cubed, I need a 3 and one more x. Okay. We're going to multiply it through. It's 3x cubed, and it'll be plus 12x. Let's line that up here. Now don't forget, we have to come in and subtract. That's going to leave us with, this zeroes out. A negative 2x squared and nothing is just negative 2x squared. 12x minus 12x. Should be my x there, goes away, and then I'm going to bring down the minus 8. That's my first round. Let's do round 2. What do I do to x squared to make it a negative 2x squared? I need a negative 2. Multiply through, so we get negative 2x squared minus 8. I'm going to come on in and I'm going to subtract, so I change the signs, and I'm left over with 0. So the remaining factor that I got here was 3x minus 2. So 3x minus 2 is a factor. Fine. Set it equal to 0 and solve. That gives me 3x equals 2. So the other solution to this was x is 2/3. So all the answers are 2/3, 2i, and negative 2i. Now let's look at the one here from start to finish. This example says that we are given the fact that negative 1 is a zero of this function. This is a third degree polynomial. By the way, when we graphed it, here's what we got. And it does look like negative 1 is a zero. By the way, I can confirm it is because their y is 0, negative 1 is the answer. So I do agree. Now, I don't see any other real zeros in the graph. So that means negative 1 either happens 3 times or there is a pair of imaginary answers. The only thing I can do is take this 0 and make it a factor and long divide it out of here and see. So let's set up the long division. 4x cubed plus 6x squared plus 5x plus 3. It's in standard format, no missing terms, so it's going to work. And the 0 was negative 1, so the factor is x plus 1. And let's start the long division. To make an x, a 4x cubed, I need a 4 and an x squared. Multiply through, and that'll be plus 4x squared. Come on in and subtract. So when we add down, This goes away here. 6x squared minus 4x squared is going to be a 2x squared. And then bring the other two components down. And we start all over. To make an x a 2x squared, we need a 2 and one more x. So we'll do plus 2 and another x. Multiply through, so we get 2x squared plus 2x. Come on in and subtract everything. It's going to leave us with, this cancels out, 5x minus 2x is a 3x. And then we're going to bring down the 3. The last step to make an x a 3x looks like we need a plus 3. Multiply through, we get 3x plus 3. When you subtract, you get 0. There is no remainder, so it's factorable, and we notice we have the final factor as this. Now, that's a quadratic. I'm going to see if it's factorable to find the zeros. I prefer factoring. If it's not, I have to do quadratic formula. So I'm just going to write that over here in the lower left corner, and let's just play around and see if it's going to work. The x squared is there and there. It's either going to be a 4 and 1 or a 2 and 2 combo. I'm going to try, maybe it's 2 and 2. Such that factors of 3 are going to go here and here, and we're trying to get the middle term of 2x. So if I put factors that multiply to positive 3, maybe it's plus 3 plus 1, but that's going to give me an 8x for my middle term, so that's not going to work. Maybe I should switch this to a 4 and a 1, or I should put the 1 here and the 3 here. I can tell you, unfortunately, this one is not going to be factorable. So I could try more, but it's not going to help. I'm going to have to do quadratic formula. So let's go ahead and do the quadratic formula. I'm going to identify A, B, and C. A is 4, B is 2, the C is 3. And let's write it out. So what we're going to get here is x equals the negative b plus or minus the square root b squared minus 4. The a is 4, the c is 3, all over 2 times a. And I'm just double checking I put that in there, right? Looks good. Let's simplify. So negative 2 plus or minus the square root of 4 minus, when we do this one here, 4 times 4 is 16. 16 times 3 is 48, so negative 48 all over 8. Continuing on, let's see here, we're going to get a negative 2 plus or minus the square root of, we're going to negative 44 all over 8. Now I am going to break this into the two pieces right up front here. So that's going to give me negative 2 over 8 plus or minus, I'm going to pull out this negative by making it an I right now, square root of 44 over 8. And then I have to notice here, by the way, the square root of 44 is the square root of 4 times the square root of 11. So I can actually pull out, make it a 2. So let's simplify this. Negative 2 over 8 is going to be equal to negative 1/4 plus or minus. Now the square root of 4 is 2. Square root of 11 stays there. So it's going to be 2 times the square root of 11 all over 8. And I don't want to drop my I out of there. Now I'm not quite done with this answer. I'm going to bring it right over here. So it's negative 1/4 plus or minus. Be careful. 2 over 8 can be simplified. That crosses off. This will be 4 on the bottom. So I'm going to have an I on the top, the square root of 11, and then 4. So we have two answers right here, along with the first one they gave us of negative 1. So we found all 3 zeros for this problem. The other two were imaginary.